Hey there, this is MathCamp321 presenting the solution to question number 19 from the PARCC Algebra 2 practice test. In this question they're giving us a system, and it's a blend of a quadratic equation and a linear equation, and it says, or it asks, how many points of intersection does the given system of equations have? So they're not asking us what are the answers, what are the points of intersection, they just are asking how many points of intersection are there. So I think the first thing that I'm going to do is just fiddle around with this manually first, and then I might confirm my conjecture based on the graphing calculator. So let's look at the top equation, which is the quadratic, and I'm just going to rewrite this in the following way. Negative x squared plus 1. Now, the graph of a quadratic looks like a parabola, and this particular parabola is shifted 1 unit up, but is also turned upside down because of the negative out in front. So I'm going to go ahead and in blue I'm going to draw this upside down parabola. Okay, now let's focus on the bottom equation, and this bottom equation is a linear equation, so I'm going to make it look like y equals mx plus b by swapping the negative x and the 2, their positions. So I'm going to write negative x plus 2, and maybe by doing this it'll become more evident that it's in this template of y equals mx plus b. So what this is a line with a slope of -1 and a y-intercept of +2. Now this parabola was shifted up 1, so I'm going to have to put one more tick mark for this y-intercept of 2. And this line is going to have a negative slope, and it's going to pass through that point too. So I'm going to just sort of eyeball what this is going to look like. So the red line could look like this, but I haven't taken many steps to make this very, very accurate. So this is really just a rough sketch. And for all I know, if the red line were tilted down a little bit more, maybe it would hit the blue parabola. Right now, the way that I've drawn this, the red and the blue graphs don't cross at all, so there are none. But who knows, maybe I just didn't draw it very good. So now I'm going to confirm with the calculator and see what the calculator tells me. So I'm going to cue the calculator up, I'm going to go to the y equals screen, and under y1 I'm going to put in 1 minus x squared, and for y2 I'm going to put 2 minus x. And I'm going to press zoom 6 to start. That gives me a standard 10 by 10 viewing window. And when I do this, when I look at the graph on the graphing calculator, it seems very, very similar to what I had done manually. And it doesn't look like the red and the blue graphs are going to cross. Or should I say, it doesn't look like the line and the parabola are ever going to cross. So therefore, there would be no points of intersection. But I'm going to do one more thing real quick. I'm just going to zoom in by doing a zoom box just to take a look a little bit more closely, because I feel like I'm a little bit far away with this particular window. So I'm going to do this zoom box feature by creating a box which I can then zoom in on a specified region, captured by this box. So I'm going to use this rectangle right here, this box, and once I'm happy with it, then I will press enter, and that'll become the new window. So here I go. So there's the parabola opening down, and there's the line with the negative slope. And I think it's pretty clear that these graphs have no points in common. There's no point of intersection. So for that reason, I'm going to select for my answer that there are no points of intersection, so I'm going to put answer choice A.